Assalamu alaikum, my dear students. I welcome you again in my class of Cambridge Sciences, where we are completing the specimen paper 4 of Cambridge IGCSE Chemistry 2023. So we are going to complete a rest of the 3 questions which were left in part 1 and part 2. So let us start from question number 5. It says a student investigates the progress of the reaction between dilute hydrochloric acid and an excess of large pieces of marble calcium carbonate using the apparatus shown in figure 5.1. So as you can see that here are an excess of large pieces of marble calcium carbonate which are added to dilute hydrochloric acid, and this is the syringe connected, which is for collecting the gas formed during the reaction. In A part, a graph is given. A graph of the volume of gas produced against time is shown in figure 5.2, having volume of gas produced in centimeter cube on y-axis and time in second on x-axis. All right. So the first question is state how the shape of the graph shows that the rate of reaction decreases as a reaction progresses. So if we go back, so you will see that the gradient is decreasing. Okay, it clearly shows that the rate of reaction decreases. So you will write as the gradient decreases, right? Suggest why the rate of reaction decreases as the reaction progresses. So it's very clear because acid is being used up, so the concentration of acid is decreasing. All right. So the concentration of acid is decreasing. Or you can write also that the particles of the reactants, they are changing into the particles of the product, so obviously leaving behind less number of particles of the reactants, so obviously there will be less frequent collision between the reactants particle to slow down the rate of reaction, right? Deduce the time at which the reaction finishes. So if you consult the graph again, so you can see that we are getting a flat horizontal line at 200 seconds, right? So this is the time where the reaction finishes. So our answer is 200 seconds. B part, the experiment is repeated using the same mass of smaller pieces of marble. So it means you are increasing the surface area, right? The smaller the piece, larger the surface area. Increasing surface area. All other conditions are kept the same. Draw a line on the grid in figure 5.2 to show the progress of the reaction using these smaller pieces of marble. So you just increase the surface area, so there will be an steeper curve. Okay, so it will finish earlier but will not increase the level of or the volume of carbon dioxide gas. So you can see the reaction finished somewhere around 100 seconds, but it produced the same amount of carbon dioxide. Right, so moving on, C part. The original experiment is repeated at a higher temperature. All other conditions are kept constant. So you are increasing temperature. The resulting increase in a rate of reaction can be explained in terms of activation energy and collision between the particles, right? So define the term activation energy. It is the minimum amount of energy. So you can say that minimum amount of energy required for a chemical reaction to take place. Chemical reaction to take place. Or you can write minimum amount of energy required for the reactant's particle to react or to interact or to collide with each other, right? Explain why the rate of reaction increases when temperature increases in terms of activation energy and collision between particles. So you can write 3 valid points to get 3 marks, right? So the first mark, for example, if you are increasing the temperature, so what happens? Obviously, so particles, they gain energy, right? So you will say that particles gain energy, right? And when they gain energy, so what is the next? They will move faster. Clear? And the total energy of the particles, now it becomes greater than the activation energy. So you can write that the energy of the particles after gaining energy it exceeds the amount of activation energy. So energy of the particle becomes greater than the activation energy, right? So particles, when they move faster, they will obviously collide faster, so there will be a more frequent collision. So there will be more frequent successful collision or effective collision So definitely more particles of the products or more products will be formed in the prescribed time or in a given period of time. All right, so these are the 3 valid points. You can get all the 3 marks. Moving on, the next question number 6, which is from the organic chemistry. Alkynes is the 3rd homologous series of hydrocarbon after alkanes and alkenes. Right, so and alkenes and alkenes are homologous series of unsaturated hydrocarbons. So when there is a double or triple covalent bond between between 2 carbon atoms in a hydrocarbon, so hydrocarbon is said to be unsaturated because more atoms can be added by breaking the double or triple bond. Okay, the second or third bond would be or can be broken and more atoms can be added, so they can undergo addition reactions. So that's why they are called unsaturated hydrocarbons, right? So all alkynes contain carbon triple bond carbon. So complete table 6.1 showing information about the first 3 alkynes So you can see that this is the alkyne of 2 carbon atoms. Eth indicates 2 carbon atom, and ine means there is a triple covalent bond. So what the name can be given to this alkyne, it has 3 carbon atoms. So for 3 carbon atom we use prop, and as there is triple covalent bond, so we will write propyne or prop 1 ine, because there is the triple bond between first and second carbon atom, right? So let us complete the table by writing the formula of but 1 ine. So it's also again very easy. So there are 4 carbon atoms in the chain, 4, okay? So as it is a homologous series, so you can increase 2 hydrogen from the previous member, okay? And or you can also write 6 hydrogen after counting the number of hydrogen you can see in the molecule, right? Compound in the same homologous series have the same general formula, give 2 other characteristics of members of give 2 other characteristics of members of a homologous series. So if they have same general formula, so also they have same functional group, right? If they have same functional group, because functional group describes the chemical property of an organic compound, so obviously they all have the same chemical properties since they have the same functional group, same chemical properties, right? And more characteristics are there. For example, there is a trend in physical properties, and there is a difference of 1 carbon and 2 hydrogen atom between the 2 consecutive members of a homologous series, and also the method of preparation of all members in a homologous series is also the same, right? Deduce the general formula of alkynes. Use information from table 6.1 to help you. So if you go into the formulae of alkynes given in the table, so you will find that whatever be the number of carbon atoms, hydrogen is 2 less than the double, so 2n minus 2. Alkynes are unsaturated. Describe a test for unsaturation. So for unsaturation, because as I told you earlier that they basically atoms can be added to the molecules of alkenes and alkynes, okay, because the second and third bond can be broken and more atoms can be added. So if we add bromine water to the unsaturated hydrocarbon like alkynes or alkenes, so the color of bromine water, which is originally brown, it will turn colorless because bromine atoms, they will be added to the molecule, right? So brown color of bromine water turns colorless, right? Coming to the last C part, ethene and but 2-ene are alkenes. Draw a displaced formula of but 2-ene. So it's very easy to draw the displaced formula of any hydrocarbon. But means 4 carbons are connected or bonded in series, right? 2-ene means there is the double bond between second and third carbon atom, right? And as it is hydrocarbon, so apart from carbon it will have only hydrogen. So complete the valencies of carbon, the remaining valencies of carbon with hydrogen. So there are 3 bonds, or you can say that carbon has 4 hands, right? So, and hydrogen can shake only one hand to or with the carbon. So there are 3 hands of this carbon are already engaged, one with right neighbor carbon and this 2 with left neighbor carbon. So only one hand is left for hydrogen. Similarly here also one hand is left for hydrogen, and this carbon has 3 hands left because only one hand has been engaged with the neighbor carbon, right? So this is the structural or displayed formula of but2ene. Draw a dot and cross diagram to show a molecule of ethene. So if we show dot for carbon electrons of carbon atoms and cross electrons of hydrogen atoms, so you know that in ethene carbon is bonded to carbon by means of double covalent bond, means 2 pairs were shared between 2 carbon atoms, right? And means 2 hands they have shaken with each other, so leaving behind 2 hands, so they can shake only one hand with one hydrogen because hydrogen is having only one hand to shake. Okay, so this is how this carbon has completed all 4 electrons, 2 bonded with the neighbor carbon and 2 individually with hydrogen atoms, right? So similar case will be here, hydrogen. So this is how we can easily complete the dot and cross diagram of ethene molecule. Moving on, D part, ethene can be converted to ethanoic acid by a 2-stage process. In stage 1, ethene is converted to ethanol by catalytic addition. So if you remember this reaction, that ethene gas is passed through steam at a certain condition, and the conditions are concentrated phosphoric acid is used as catalyst, and 400 degrees Celsius temperature and 70 atmospheric pressure. So these are the conditions which are provided for this reaction to take place, right? So just why stage 1 is called an addition reaction. So addition reactions, you can see that there are 2 reactants, they are added up together to form just only one product. So when one product is formed from 2 reactants, so a reaction can rightly be called as an addition reaction, right? So you can write that as only one product is formed. During the reaction. Okay. A catalyst is used in stage 1. State one other condition that must be used, as we discussed earlier. So apart from the catalyst, we have to mention any other condition, and that is high temperature, right? High temperature means almost 400 degrees Celsius temperature, or you can also write 70 or 60 atmospheric pressure. So high temperature and pressure are the other conditions. State O must be the reacted with ethanol to form ethanoic acid, right? Ethanol is oxidized to ethanoic acid. So oxidation reaction would take place for ethanol to convert into ethanoic acid. So we use oxidizing agent like KMnO4. So acidified potassium manganate, which is a powerful oxidizing agent, can be used for ethanol, right? And ethanol can be converted into ethanoic acid. Question number 7, I think it is the last question of the paper. Carboxylic acid can be converted into esters, right? So propanoic acid and methanol. So you know that esters are the products formed when carboxylic acids, they react with alcohols. So propanoic acid is a carboxylic acid and methanol is an alcohol. React to form an ester that has the molecular formula C4H8O2. So name this ester and draw its displaced formula. So name out of the ester is very easy to tell. Why? Because we know that we would see that what is the alkyl group in the alcohol. So methanol has methyl group, so we will write the name of the alkyl group migrated to form the ester will be written first. So methanol has methyl alkyl group, so we would write first methyl. And propanoic acid, as hydrogen is removed and methyl group takes place of the hydrogen of propanoic acid. So when hydrogen is removed from the carboxylic acid, it is called carboxylate in general, and specifically for propanoic acid it will become propanoate, right? So this is how we can write the name of an ester. Methyl propanoate will be so for drawing the displaced formula of ester, also again it is very easy to draw. First of all, draw the structure of propanoic acid. Propanoic acid means there are 3 carbon in chain. The first carbon is the carbon of carboxyl group, and then complete the valencies of carbon with hydrogen. So this is the structure of propanoic acid. So what you have to do, you have to remove this hydrogen, and this hydrogen will be replaced by the alkyl group of the alcohol, and that is methyl CH3. So this is the displaced formula of ester. Name another ester with the molecular formula the same, means C4H8O2. This is the same molecular formula. So how can you write another ester, name of another ester? So let us understand, if we take 1 carbon out from the propanoate and we will just cut and paste over here, so methyl group will become ethyl group, right? So there will be 2 carbon in this group, so methyl will become ethyl. So ethyl, and when you reduced 1 carbon, so this part has become now ethanoate, as there are only 2 carbons left. So ethyl ethanoate will be the name of another ester with the same molecular formula. B part of this question, polyesters are polymers made from dicarboxylic acid, means there are 2 carboxyl group attached in the molecule, 1 carboxyl at one end of the molecule and the other carboxyl group at the other end, right? So name the other type of organic compound used in the formation of polyester. So polyester has ester linkage between the monomers, right? So there should be diol or dialcohols, or you can say the alcohol molecules which have 2 hydroxyl group, hydroxyl at one end and hydroxyl at the other end. So diols are the second organic compound, can react with dicarboxylic acid to form polyesters. Name the type of polymerization used in the manufacture of polyester. There are two types of polymerization: addition and condensation, right? So when the linkage is formed followed by the elimination of a smaller molecule like water or hydrogen chloride or something like that, so this is called condensation polymerization too. So here also, when the functional groups of dioic acid, dicarboxylic acid, and diol, they combine with each other, they make the linkage between each other. So OH from one monomer and H from other monomer, they combine to form water, and water is released and the linkage is formed. So this kind of polymerization is called condensation polymerization. Okay, I hope you find this video useful for you. If you like this video, share with your friends and subscribe to the channel so as you can get more beneficial videos from this channel. If you have any confusion or doubts, you can write a comment in the comment box. So till the next video, wassalamu alaikum wa rahmatullahi wa barakatuh.